Video was not quite as good as it was last time. I think we're up to about 75. I'm just referring to completion. I think we're about 75% complete. Last time we were about 85% complete at this point. So there could be some of you that forgot it, ignored it, whatever it. Right now, well, soon you'll have a 0 in there for that. If you want to go back later and rewatch the video, you're welcome to it. So based on your hopeful success with that video, I would say that a question like number 4 in your notes here would be something you could probably do. So if you would, in your notes, on paper, please try your warm-up number 4. Hey. Try number 4 as a warm-up. You're close. What's the coefficient on the middle one?
1.
So they're all like radicals, right? Like the video. So 5 plus...
it'd be
5 root m plus 1 root m would be how many root m's?
6.
6 of them. And so 6 minus 9...
3.
Negative 3. There you go. There you go. Okay, cool. How's it going?
Add this, or this, and then you subtract it by this.
So what's the coefficient on this one right now? The
1.
coefficient is 1. Yep.
Yeah. So you do 5 plus 1, and then minus 9.
Yes, I guess that's
6.
Okay. How's it going? It's a 1. Yep, it's understood to be a 1. Exactly. Just like a, like an x is a 1x. Same idea. Exactly the same. Okay. How's it going with the warm-up? Right. Interesting. So you 3 are not right. I think what's going on, think about the coefficient on the middle term. It's a 1 root m. Yep. Just like if you see an x, it's understood that it's a 1x. You see a root m, it's a 1 root m. There we go. I figured that's what it was. Okay, so I think I've seen everybody here. Okay, guys. Hey, listen up. Let's go ahead and check this one out. So if you remember from the video, the intro video, when you're adding radicals like this, in order to add them, they have to be like radicals. Just like in the past, we looked at terms that were added together. They had to be like terms. These have to be like radicals. And please notice that all of these are like radicals. They're all root m's. So they can be added up, all 3 of them. The one thing as I walked around, the one potential struggle point was understanding what the coefficient on the middle term is. If there is no coefficient written, it's understood to be a 1. And so I would say that that's a 1 root m there in the middle. So when I add these up, I'm going to leave the radicals the same. And I'm going to add and subtract my coefficients. So 5 root m plus 1 root m would be 6 root m. And then we still have that minus 9 root m. And then 6 minus 9, of course, is negative 3. So negative 3 root m would be your final simplification for that one. Okay? Do you have any questions, any follow-ups there? Okay, so we're going to do, I think, 3 examples here. They're going to be a little bit different. And we'll see how we all do with those. And here they are. Okay, so let's see here. I'm going to do, I guess we got 4 examples instead of 3. I'm going to do, I'll do number 5 and number 6 with you, and we'll see how it all goes and see how far you can go on your own. Take a look at number 5, root 10 plus root 6. Guys, check this out. When you first look at these 2 terms, don't you look at them and say, hey, wait a minute, those radicals are not like radicals, right? One radican's a 10, the other one's a 6. And so you might come to the conclusion that since they are not like radicals, we just simply can't add them up. You might be right, you might be wrong. In order to tell for sure, we need to simplify the radicals all the way down to their lowest, the most simple form. And so we need to think of our prime factors. So what are the prime factors of 10?
5 and 2.
Okay, so that's 2 times 5. Prime factors of 6? 2 times 3, yeah. So when you look at that right there, when I look at this 2 times 5, there's no pairs of 2s or pairs of 5s, right? So I'm not going to be able to simplify that root 10. The root 6, there's no pairs of 2s. There's no pairs of 3s, so I can't simplify that either. So in other words, These two radicals, as originally stated, they're already as simple as they can get. And so when I look at root 10 plus root 6, I got to say, I can't add those up. They're unlike terms. They're unlike radicals. Okay? So this would be like if you saw something like x plus y, and you were going to try to add those up. You'd ultimately have to look at those and say, well, they're unlike terms, right? One's an x, the other one's a y. They're not like, so I can't add them up. That's really kind of like number 5. Okay? Does that make sense? So you might see some like that. I would say that that'd be rare. I think we might see problems like number 6 a little more frequently. We'll take a little bit more time with number 6. With number 6, couldn't you easily look at number 6 and say the same thing? Right? One radican's 54, the other one's 24. They're unlike radicals, therefore they can't be added. But you're going to find that these actually can be added if we look at them being simplified. So let's think about the 54. I'll just do this off to the side here. What are the prime factors of 54? So we could do 9 times 6, neither of which is prime, but we can keep breaking them down. What's 9? 3 times 3, and the 6 would be? You got it. So square root of 54 is really square root of 2 times 3 times 3 times 3 plus, let's do the same thing with 24. 6 and 4. 6 is really 3 and 2. 4 is 2 times 2. Okay, so 24 is 2 times 2 times 2 times 3. So I'm hoping that so far what we've done here, it just feels a lot like what we've been practicing. And although what we're doing right now is not on tomorrow's quiz, I think it's still good practice, right? What we're doing, I think, really fits well with some of the skills you'd need. Okay, so over here, got a pair of 3s. And so that comes out as a single 3. But the 2 and the other 3, they don't have anything to pair with, so they're left. So it's 3 root 6. Over here on the right, there's a pair of 2s. So those get to come out as a single 2. The leftover would be a 2 times 3, which is 6. So now, when you look at these radicals, do you see how they really were like radicals? They really were, yeah. They're both root 6s. So just like you did a minute ago, we can add these up. Say 3 plus 2 is 5. We'd end up with 5 square root of 6. 5 times the square root of 6 for our final answer, final simplification. So before you make a judgment and say, oh, those are unlike radicals, they can't be combined, simplify first. And I think you might find that, yes, actually, they can be. So if you guys would flip over to number 7 and 8 on the other page, I think you'll find some similar examples to practice. So give it a shot. Ready to go. The first one, when you simplify, becomes 7t root 3, and the other one becomes 4t root 3. So once you do simplify those, you end up with 11t root 3. And walking around, I saw a really nice job on those, on that one. Number 8, a little more challenging. Got quite a bit of simplifying to do. Square root of c squared is just c, so this would be 9c. There's no simplifying that can be done there. There's no simplifying that can be done there. There's no simplifying that can be done there either. But on the last one, the square root of 4c, isn't there a pair of 2's in there? So you got a pair of 2's that can come out as a single 2, so that would be minus 2 root c. So you want to try to simplify everything. Now some things can and some things can't be, so don't overdo it. But you want to try to simplify everything. So now as far as like terms go, this 9c is like this 5c. That would give us 14c. And then in all honesty, everything else is also a like term, a like radical. So negative 4 root c minus 2 root c is negative 6 root c. That would be your final simplification for number 8. Okay? Yeah, I think that's about it. We got about a minute left here. Let's